as human beings, we don't communicate in a way that is nice and easy for computers to understand. We talk to one another, we send messages, we send emails, fill in reports, and that we communicate through language. And computers find it difficult to interpret language, which is one of the most interesting areas of AI for me. It's natural language processing, or trying to extract meaningful data from that free-form text. We don't communicate by tick boxes and filling in a nice form or numbers. There are subtleties in our speech and the way we talk that are entirely contextual based. Now, the particular area I want to talk about today is this. And this is a safety observation card. It's quite widely used in industry to track safety trends, to see what's going on, and to try to adapt safety systems to reflect and protect the workers. And we can see here, this is just a generic one I got off the internet. You can see here, date, where the incident happened that's being reported, whether it was caused by behavior or a condition, nice little checkbox, and some more checkbox is as to whether the incident was related to PPE, tools and equipment, communication, body position, manual handling. And this is where most of the analysis is done, is using this information up here. But actually, most of the information, most of the data is contained in these three boxes. This is the narrative. This is the story of what happened. And it's extracting information from here that actually shows the real trends. So I'm just going to show you quickly a little technique called topic modeling, which uses semantic tools to try and extract underlying trends in a large data set. And I feel that actually it would be quite interesting to work with this, looking at safety incidents. So if we jump into the computer, I will just talk a little bit more about what we're doing and how to do this. Right, let's just open up a new Jupyter Notebook, and we'll just rename it. Just to let you know, the dataset I'm using here I sourced from the Government of Western Australia's Department of Mines, Industry Regulation and Safety, and it's a series of mining accident reports that we can carry out analysis on. The important part being that most of the report's data is in that narrative text that I mentioned earlier. Right, so just import the libraries that we're going to be using. Okay, so I'm just importing Pandas, Count Vectorizer, and TF-IDF Vectorizer from sklearn. I'm also importing LDA, I cannot say the full name, from sklearn decomposition, and NMF. These are going to be our two topic modeling tools that we're going to use. Okay, so now I'm just going to import the data from a CSV file that I downloaded earlier. Okay, let's just have a quick squiz at the head and so on, and there we can see already done a bit of pre-processing, so we've just got the free-form text. And I'm just going to show you one of the reports in full here, and there we can see there is quite a lot of information there, and using traditional analysis systems this could be lost. So I'm just going to initiate call my instance of Count Vectorizer, and this is where I'm setting the min and max parameters. I don't want words that occur in more than 95% of the reports. I'm also going to make sure that the minimum is 2 words, so that any spelling mistakes and words that only occur once are dropped and don't effect analysis. I'm also going to call stop words the English stop word dictionary. Right. So I'm just going to create my document term matrix by using my instance of the count vectorizer on my corpus or my selection of text there. And this will convert the text into a form that the algorithm can understand. You can see that it's a sparse matrix now. And if we just have a look at, yeah, okay, so we can see that we've got 1,553 reports, and we can see that in the document term matrix we've still got 1,553 reports and 2,176 unique words used within those reports. Okay, so let's call an instance of LDA. Now you choose the number of components that you want to break your cluster into, and I'm using 15 here just because it's the number of categories that they have on their website for the incident types. You can choose whatever number of clusters you want, but this is where it's useful to have a bit of domain analysis or domain understanding. Right, so there we go. Okay, so now I'm just going to loop through the results and have a look at the most important words that help identify each topic. And to do that, we'll just use a little bit of f-strings and list comprehension. So I should mention that earlier, actually, that the top modeling actually requires a bit of human interpretation. The algorithm will tell you what it views as the most important words in each topic, but it's up to the human being to interpret each topic and what that topic is. Okay, and if we just run that sound, yep, you can see we get here the top 20 most important words for each topic. Okay, so what I'm going to do now is just ensure that each of the safety reports that is in the data frame we created earlier have the appropriate topics added in a separate column so that we can have a look at which topic is relevant to which safety report. So what I'm going to do now is just have a look at a couple of the cards that have been allocated to topic 15, because looking at the associated words, it looks like that the topic is something related to gas underground in the mining industry. And what I'm going to do now is just loop through the top 5 cards and print them out using f-strings so you can see the cards in full. And yeah, looking at these cards, we can see that there's an awful lot of information about gas incidents in safety reports. in underground diamond drilling events. So what I'm going to do now is show you another method of topic modeling using non-negative matrix factorization. And the first thing we're going to do is call an instance of TF-IDF factorization, because we're going to use a term frequency inverse document frequency matrix. And you can see we're just using the same settings and parameters for our TF-IDF factorizer as we did for our count factorizer. So I'm just going to call our TF-IDF instance on the corpus and create our document term matrix for non-negative matrix factor. Okay, now time for our NMF instance. And we're just going to call it in the same way, using the same settings as we used for our LDA, those 15 components, or 15 clusters that I mentioned before. Okay. And just fit the NMF instance to our document term matrix. Okay, and there we go. So we're just going to explore the top 20 most relevant words again, using the exact same technique. Right, so if you remember, I'm just going to loop through and show you the most relevant words for each topic, or the top 20 most relevant words for each topic. And the reason I'm showing you a different method is because the different topic modeling methods will cluster the reports in different ways. So it could just give you an idea of different underlying topics that might be occurring. And again, it's about human interpretation at the end of all of this as well. Yep. What have I done? Oh, forgot a set of brackets. Right. And there we can see those words for each topic that I was talking about. Now, if we just scroll down to topic number 15, which from the previous instance was all about gas underground, you can see that that's definitely not the case in this cluster. So it takes a bit of time to look at and interpret the different clusters. It's definitely worthwhile. And now I'm just going to add the different way that the cards have been classified to that data frame earlier, so that we can look at how the different methods have clustered the safety reports accordingly and demonstrate that they do cluster everything in a different manner. So just print out the head of the data frame, and we can see here the topic 14 to 14, another topic 14 under LDA, and they've all been classified differently using NMF into different clusters. And here's a 2 that's been classified as a 14 NMF, and 2 that's been classified as 11. Now remember, these cluster numbers are just arbitrary numbers according to which cluster number they've been clustered into. The meaning has to be extracted through human interpretation. So if we just get every card that's been classified into topic 15 using NMF, and then we can see how they've been classified as LDA topics. And let's just look at the head of the new data frame. Okay, and here we go. You can see that there's definite split across different clusters according to which method you use. And now I'm just going to do what I did before, and I'll print out the first 5 cards in full so that we can have a look at how NMF has clustered the cards and see if we can see a trend. Okay, so let's have a look at the cards. I'm genuinely not sure what the link here is for clustering, so we'd need to get a bit of domain expertise in to have a look at this. Potentially, there's maybe a link with Seismic. Right, so what I'm going to do now, just to have home the point about different methods clustering different ways, I'm going to print out both sets of cards next to one another. Again, both of them cluster into the topic 15 by each unique method. But just want to remind you again, these numbers are completely arbitrary. They just link what the algorithm thinks is connected topics. So there we go, point hammered home, different methods, different clusters. I hope that's been of interest to you and has given you something to think about in the ways that you can carry out some basic text analysis to give you an idea of what's going on in safety systems or within your safety reports and maybe some underlying hidden trends.